Today's topic is language and the brain. That's a very interesting topic because people have been searching the answer to this question: where is language located? It has a long history. Different philosophers, surgeons, doctors, psychologists, and linguists, language experts, they have tried to locate language in the or simply they tried to find out the answer to the question: where is language located? What is the code, or what is the connection between language and brain? So there are four topics, subtopics in language and the brain that we are going to discuss today. First is neurolinguistics, connection of language and the brain or mind, structure and foundation of brain lobes, and maturation and invariance hypothesis. So, language and the brain, the birth of neurolinguistics. Does language live in one corner of the brain, or is it the song of an orchestra whose instruments span the entire neural landscape? This question is not trivial. For 2 centuries, it has divided science into two camps: the localizers, who believe that specific brain regions are hardwired for language, and the distributionists, who see language as the emergent property of vast interconnected systems. To answer it, we must enter the brain not as a tourist, but as an archaeologist or as archaeologists of thought. The question is, if tomorrow you lost one part of your brain, would you still be you? Or would you become a different self? I have posted links as well, and I've posted these notes on Medium, so you can click the links and you can also explore other sources as well when you are watching. After that, I'll give the link and you can watch it as well. This video is based on my blog post on Medium, so you can read that post as well, and you can explore more as well. Now, let's come back to the point: origin of neurolinguistics. Clinical birth, 19th century. Broca, Dr. Paul Broca's patient Tan, 1861. Tan could comprehend language, but he could only utter Tan. That is why he was called Tan. Tan was not his word. Tan was the only syllable he could produce. So that is why he was named Tan. Postmodern analysis revealed a lesion in the left inferior frontal gyrus, now called Broca's area. So this is how we found one important secret through Dr. Paul Broca, whose patient had a problem. He couldn't comprehend language, and Dr. Paul Broca discovered that. And he proudly said that I've discovered the language area, or where this language is located. Second big name is Wernicke. Carl Wernicke, 1874, he identified patients with fluent but nonsensical speech and poor comprehension. Lesion in the posterior superior temporal gyrus, that's called Wernicke's area, and thus emerged the localization hypothesis that speech production and comprehension are partially segregated. Now, if you have map or Broadman areas, 52 areas, you can see Broca's area will be area 44, and Wernicke's area will be area 22. And with Broca's area 44, you will also find area 45. So area 44 is syntax, area 45 is semantics and syntax interface, and area 22, that is about comprehension. So through Dr. Paul Broca and Carl Wernicke, as scientists, they discovered this localization, or these exact parts. These are called uh, these are the important secrets, or important sources, or important areas that establish the connection of brain and language. Next important name is 20th century Carl Leschly's equipotentiality hypothesis. Brain functions are distributed Damage can be compensated by other regions. And I have given the link to this article. You can, when you read my uh, post on Medium, you can click and you can read it full. It's very interesting. Lannenberg's maturation hypothesis, 1967, that was language is biologically programmed but unfolds with brain maturation most efficiently within a critical period. That is, you can learn language at an early age. Once that time is passed, you won't be able to learn it as proficiently with the same ease as. Now, here, you can look at young children. When they learn a new language, they learn sounds or accent or pronunciation like native speakers. But when they are learning, when it comes to old people or grown up people with past puberty, they face difficulty in speaking like native speakers. But here it's very important to note that syntax and semantics, old people, grown up people, they can learn it very well. But speaking or accent or pronunciation, here, young children, they have a clear edge. So this needs to be studied carefully. Renaissance, 21st century. fMRI, PET, EEG, MEG show distributed networks. Language is not light bulb, but a city's power grid. Modern imaging, fMRI, PET, EEG, MEG, these modern imaging reveals a distributed language connections where syntax, semantics, and phonology are processed by overlapping dynamic networks across the cortex and subcortex. Competing hypotheses, localization hypothesis. Strength of localization hypothesis, its historical precision, clinical utility, like aphasia diagnosis. Weakness is it oversimplifies complexity and neglects plasticity. Distributed or network hypothesis, its strength is supported by neuroimaging, accounts for compensation after injury, and weakness is risk of vagueness. If everything is everywhere, then explanatory power weakens. That's, I mean, the weakness. Maturation hypothesis, strength is supported by L2 acquisition studies, recovery from brain injury in children. Weakness is fails to explain exceptional adult learners. Invariance hypothesis. Here, its strength is certain regions like Broca's area always recruited, regardless of age. Weakness is ignores developmental plasticity and individual variation. Evidence. There are different experiments that change the field. Broca's aphasia case, TAN, birth of localization. Split brain studies by Gazaniga 1967 revealed hemispheric specialization but also adaptability. ERP studies, Kutas and Hilliard 1980s. N400, brain's semantic anomaly detector. I take my coffee with sugar and socks. So here the word socks, that is something that is anomaly. So N400 shows semantic anomaly. P600 shows syntactic reanalysis. The cat was chasing the dog. Usually it's the opposite, the other way around. Dogs chase the cat. Neuroimaging, Binder et al. 1997. Semantic processing distributed across frontal, temporal, and parietal cortices. Multilingual aphasia studies, they show that recovery patterns vary by age of acquisition, emotions, salience, and frequency of use. Now, what you can do if you're teaching psycholinguistics, you can try these, like present a normal sentence. The children ate the cake. Present an anomalous one, like children ate the guitar, and ask what feels strange faster. So that's kind of simulation of N400 effect. Uh, Neuroscience of language. The neuroscience, frontal lobe, Broca's area, syntax, planning, and articulation. Dorsolateral prefrontal cortex, working memory and attention. Temporal lobe, Wernicke's area, lexical access, semantic and mapping. Anterior temporal lobe, semantic memory. Parietal lobe, that is multimodal integration, reading, sign language, comprehension. Occipital lobe, visual word formation form area, orthographic recognition. Subcortical structures, basal ganglia, sequencing and rhythm, and cerebellum, timing and fluency. So you can check this brain activity, try this brain activity exercise. Students, they can draw lobes on a worksheet and assign linguistic functions to them. You can give it to your students if you are teaching. Interdisciplinary crossroads, psychology, critical period and second language learning, education, timing of bilingual education in Pakistan or in other countries. Should English exposure begin in kindergarten or second level? Should Pakistan introduce English in early childhood or strengthen Urdu, Saraiki, Sindhi, Punjabi, Pashto at foundation first? AI, neural networks inspired by brain connectivity models simulate language processing. AI and NLP, deep learning models mimic distributed networks. Philosophy of the mind. Is language reducible to neural firing, or is meaning irreducible? If meaning is just neural firing, what happens to concepts like soul or intentionality? Pakistani bilingual brain. Pakistan, a natural lab for code switching, bilingual education, because in Pakistan everybody speaks almost three languages: English, Urdu, and mother tongue, sometimes four. Like in Punjab, people speak Saraiki, Punjabi, Hindko, Potwari. So in Islamabad, Rawalpindi, you can see people speak more than three or more than three. So Pakistan Linguistic Ecology, English, Urdu, Punjabi, Saraiki, Sindhi, Pashto, like 68 languages. They are like a national laboratory for bilingualism, code switching, psycholinguistics. Proposed, so what you can do, ERP comparison of code switching between Urdu and English or Urdu Saraiki bilinguals. Prediction: English code switching shows higher P600 cost due to structural differences, while Urdu Saraiki switching shows reduced cost due to typological similarity. Implications: sensitive period and typological distance both influence bilingual brain processing. This is how Pakistan students can produce new data for global scholarship. There are some questions you can think about. Can the brain's plasticity make the localization of obsolete? Is bilingualism a cognitive burden or gift? Does bilingualism strengthen distributed processing or more than monolingualism? Should Pakistan redesign language education policy based on neuro-linguistic evidence? If AI mimics brain networks, is it thinking or just predicting? What does it mean for philosophy if meaning is just neural activation? You can also do some activities like write an essay, compare Lanneberg's maturation hypothesis with invariance hypothesis, and which better explains Pakistan's trilingual reality. You can also conduct experiment. You can draft a small scale ERP study on code switching costs between Urdu and English. You can also conduct a debate in the class to resolve language is localized or not distributed, or language is distributed, not localized. Or you can say, is this issue resolved or has it been resolved? Language is localized or distributed. And brain mapping tests, like students label brain lobes and associate them with linguistic functions. So the study of neurolinguistics is not a sterile dissection of gray matter. It is the story of how matter becomes meaning. The study of neurolinguistics is not merely an explanation of tissue and neurons. It is the pursuit of how the human brain becomes a hamlet of meaning, a place of meaning, a store of meaning, a manifestation of meaning. If one university investigates monolingual brains, another in Pakistan, with its rich multilingual reality, can lead the next revolution. So imagine a future where global textbooks cite not just Broca and Wernicke's area, but Pakistani scholars' work who unlock mysteries of bilingualism by uh, exploring their languages. So if you understand this knowledge, Pakistani scholars from Pakistani universities, from Namal, from Qaid-e-Azam, from University of Karachi, from universities in Balochistan, Peshawar, KPK, Punjab, University of the Punjab. So there are so many, Thal University, Bhakkar, there are many universities and thousands of students who are studying English. So Pakistani scholars can unlock these mysteries of bilingual brains. And if they have some skill and some courage and initiative, they take initiative, Pakistani scholars can dismantle the caricature of Pakistan as a land of fanaticism, and they can rebuild an image of Pakistan that is branded in as neural pioneers or at best research in bilingualism or code switching. So students whose experiments in Darya Khan, Dera Ismail Khan, Dera Ghazi Khan, Larkana, Lahore, Khuzdar, Islamabad, Quetta, Lahore, Multan will be cited elsewhere in the world. So in this way, we can turn from backward country, labeling. We can change that, and but main purpose that is not about labeling. It is about studying this science, exciting science, and trying to contribute to this knowledge. Best wishes for you, and see you again in another video very soon. Thank you. If you have any questions, you can post it.